Hi everyone, welcome to this channel. If you're new here, my name is Hasan. I'm going to start a video series on ray optics since this chapter has a very high weightage in NEET and students have hard time grabbing concepts from this chapter. Each part will be roughly around 40 to 45 minutes and I will try my level best to cover each and every topic from this chapter. I hope that once you go through this series, you'll gain mastery over this topic. Please concentrate for 40 minutes and then you're free to enjoy your life. So let's study in style. So let's understand the definition of reflection first. So this is just the introduction of the chapter. Now what is reflection? Reflection is a phenomenon by virtue of which a light beam, after interacting with a surface separating the two different media, bounces back into the same medium. So this is the definition. Please take a note of what I am saying or what you're seeing on the screen, okay, nicely, so that it's easy for you to revise the thing, okay. So simply the definition says that suppose this is medium 1 and this is medium 2. So this surface which is separating the medium 1 and medium 2, when light comes and hit this surface, then it bounces back into the same medium. So this phenomena is known as reflection of light. Simple as that. I hope this is clear. Now let me rub this. Let's move on into the properties of light. Now there are three properties of light here. The first property says that light always travels in a straight line. Very simple. Everybody knows that. Number 2, the single path of light is called ray, as you can see from the diagram, and the collection of ray is known as beam. So when in the question it says beam of light, that means there are multiple amount of rays, and when it says a ray of light, that means a single ray of light, okay. So these are easy properties of light. Now let's move on into our next part, that is laws of reflection. Now let's understand. The first law says that incident ray, as you can see from the diagram, so this is the incident ray, this one. The reflected ray, this ray is the reflected ray, and the normal is the dotted line, as you can see here, to the surface lie in the same plane. So all these rays, that is incident ray, reflected ray and normal, will lie in the same plane. Simple as that. Here the plane is actually the paper or the screen of the computer. So all of them are lying in the same plane, as you can see. Now this thing holds true for both plane mirror as well as circular mirror. Now let's see this, how to draw normal for circular mirror. For circular mirror, what you need to do is draw a tangent. So suppose we need to draw a normal at this point. So what we'll do, we'll draw a tangent at that point, and then over that tangent we'll draw a perpendicular. Whenever we draw a perpendicular over that tangent, we'll see that normal or that perpendicular line actually passes through the center of the circle. So there are two properties for normal when it comes to circular mirror. The first property is it should be perpendicular to the surface, and second is it passes through the center of the circle that is creating the circular mirror. I hope this much is clear. Easy, done. Now let's move on to our second point. Angle of incidence, that is this angle, angle I, as you can see here, this angle. So angle I is equal to angle R, that is angle of incidence is equal to angle of reflection. Simple as that. Now look at this highlighted color sentence. It says that these laws of reflection holds true for regular reflection at all kinds of surface, okay. So there are two kinds of surface that we'll be studying in this chapter, that is plane as well as curved. Okay, so these laws hold true for both plane mirror and curved mirror. Now there are two kinds of curved mirror. One is convex mirror, another is concave mirror. This picture that you're seeing, this is of convex mirror, and this is the concave mirror, okay. So for both the cases, the laws hold exactly true, okay. So I've demonstrated this with a diagram, that is I, N and R. I, N and R all lie in the same plane, and angle I, this angle, is equal to angle of reflection. In case of circular, you can see that angle of I is equal to angle of R. So it's true for both the surfaces, whether plane or curved. I hope this much is clear. Once this is clear, now let's move on to our next part, that is properties of plane mirror, because in this video I'll be discussing only the properties and the questions that are related to plane mirror only. Now let's move on. The first property says about plane mirror is that image found by plane mirror is virtual, erect, of the same size. Very important. Let me highlight this. Virtual, erect, of the same size. Okay, now what does erect means? Erect means upright. Okay, simple as that. Suppose this is the mirror and this is the body or the object AB. Erect means upright. A dash, B dash. If this is standing, this object will also stand in the same orientation. Okay, this is known as erect or upright. Now of the same size means if the object is of 6 centimeter, then the image will also be of 6 centimeter. Now virtual, what does virtual actually means? Now I will build this concept over time as the video rolls down, but as of now, since you're new to this video or new to this concept, I can say that virtual images are those images that are formed behind the mirror. Okay, so virtual images are those images formed behind the mirror, that is images formed behind the mirror. As of now, this is the simple concept that I can provide. I'll build upon it, don't worry. Okay, so suppose this is the object, then we know that for plane mirror the object is always formed behind the mirror. Therefore for plane mirror we know the image formed is always virtual, that is the image is always formed at the back of the mirror. Okay, so virtual images are images that are found behind the mirror. So always plane mirror produces virtual image. Now let's move on to our second property. Don't worry about virtual as of now, only understand this much. As we proceed through our video, we will build upon that. Okay, the image is formed at the same distance from the mirror as is the object. So simple as that. I'll draw it here. So this is the mirror and this is the object, suppose. Then if it is 3 centimeter in front of the mirror, then the image will form 3 centimeter behind the mirror. Okay, simple as that. Now let's move on to our third point. Image formed by plane mirror is laterally inverted. Very important, very important. So let me explain what is lateral inversion actually means. Okay, so let me highlight this thing. So lateral inversion means if you stand in front of the mirror, then the right side will appear to be left and the left one will appear to be right. For example, let me explain this thing. Lateral inversion, suppose this letter is B. For symmetrical object, it's very difficult to understand, but if the object is asymmetrical, then it's easy. For example, B is asymmetrical, so you'll see after reflection it will be like this, isn't it? So this is known as lateral inversion. Okay, that is, look at this side, this is the right side of B, this is the left side of B, but in the image what happened is this side became left and this side became right. Okay, so the right side became left and the left side became right. So this is known as lateral inversion. I hope this is clear, the simplest way I can put this thing into. Okay, so now let's move on to our fourth point. On keeping the incident ray fixed, if the mirror is turned at an angle theta, then the reflected ray turns by an angle 2 theta from its initial path. Very important concept. Okay, let me draw. So this is the mirror and this is the normal. Okay, it says that suppose we have incident array normally to the plane. Okay, so the reflection will also be normal. Why? Since angle I is 0 here, therefore angle R will also be 0, so that it will retrace back its path. I hope this much is clear. Now what I will do is I will turn this mirror by an angle theta. If I turn this mirror by an angle theta, then obviously normal will also turn by an angle theta, isn't it? Simple as that. If I turn the mirror by theta, then normal will also turn by theta. I should have drawn it with a different color. Okay, so let me pick this. Now let's see the same incident ray that was hitting, now it is hitting at an angle theta with the normal. Okay, therefore the reflection will also be at an angle theta, because angle I is equal to angle R from the first law of reflection. I hope this is clear. Therefore now the reflected, this is the reflected ray, the reflected ray has deviated by angle 2 theta, isn't it? Theta and theta, initially it was 0, initially R was 0, angle R was 0. That is, we can say the reflected ray was making an angle 0 with respect to incident ray. That is, this was the incident ray and this was the reflected ray. Same. Now when we turned the mirror by an angle theta, what happened is this is the incident ray I and This is the reflected ray R and the angle is 2 theta. I hope this much is clear. So if we turn the mirror by an angle theta, then we will see the reflected angle will increase by 2 theta. I hope this much is clear. So I'll read it again. On keeping the incident ray fixed, so we have kept the incident ray fixed. If the mirror is turned at an angle theta, then the reflected ray turns by an angle 2 theta from its initial path. I hope now it's clear. Okay, simple as that. Now let's proceed. Now let's move forward and see the image formed by a plane mirror. Okay, first we will analyze point object. Okay, so let me keep a point object in front of the mirror. So this is the mirror. So the point object is suppose here. So we can write that this is object. We know that the image that will form will be somewhat here. So this is the image. So if it is at a distance d from the mirror, then the image will also be at a distance d at the back side of the mirror. Now, how is this image actually formed? Let's understand the ray diagram. So the first thing is very important, that is, let me write it down, that minimum 2 rays are required for creating an image. So let me write it down, copy this thing. Minimum 2 rays are required for creating an image. Why 2 rays? Because image will be formed at the intersection of rays. Okay, don't worry, things will become clear. So minimum 2 rays are required for intersection. So let's see. Let me change the color. Let us take one ray as this one, another ray as this one. Simple. Now we know that, so the first ray, this one, after reflection will retrace back its path, and this ray after reflection will go like this. I hope this much is clear. If this is the normal, then angle of incidence will be equal to angle of reflection. Okay, this is how we got this. I hope this much is clear. So let me rub this off, otherwise the diagram will become very dirty. Okay, now this is done. So actually what is happening is, when we see this object, okay, let me draw an eye. So this is suppose eye. When we see the object, it seems that the rays are coming from the back side of the mirror, isn't it? And for this one, it seems as if the ray is coming back from here, and at this point both the rays are appearing to meet. So the object or the image will be formed at the intersection of these 2 rays. So minimum 2 rays are required for formation. We can take it in this direction also. Let us take that a ray goes from here and hit the plane, and after hitting there will be reflection, that is angle I is equal to angle R. But our human eye will see that actually the ray is coming from the back side of the mirror. This is what the human eye actually sees. Okay, so we will get the image here. Okay, I hope the ray diagram is clear. Now, since I said what is virtual image, any image that is found behind the mirror. So you got another concept of virtual image. We know this image is known as virtual image. Okay, so we see that in case of virtual image, rays appear to meet. So whenever rays appear to meet but they do not meet actually, then that kind of image is known as virtual image. Again, I'll repeat that when images are formed due to interaction of rays, but those interactions are not real, but it appears to intersect, then that kind of image is known as virtual image. I hope this much is clear. Once the concept of virtual image is clear, now let's move on to the next point. We know that the object distance, that is this distance d, that is object distance, should be equal to image distance. Okay, this thing we have already learned in the properties. Okay, so this should also be d. Okay, now how to measure this distance? This distance is actually measured perpendicular to the mirror. This is very important. Okay, I'll explain this when I'll give you some numericals. Okay, so the measurement or the object distance and image distance, that is the measurement is done perpendicular to the mirror. You can see this diagram, that is this is the object and the distance is actually perpendicular to the mirror. Okay, and the image formed, that distance is also perpendicular. This is what the statement that is measured perpendicular to the mirror actually means. Okay, this is all about the image formed by plane mirror when the object is actually point object. These are the points you need to remember. Okay, once this is clear, now let's move on to our next part. Suppose I have drawn a mirror like this. Okay, this is the back side of the mirror and I've kept an object here. So my question is, where will the image form? If you say the image will be formed somewhere like this, somewhere here, then you are absolutely wrong, because what we have learned, if you look above, it says that measured perpendicular to the mirror, that is the image should always form perpendicular to the mirror. So actually, and the distance that is measured is always perpendicular. So this is the perpendicular distance. Suppose this is D, then the image will form perpendicular to the mirror here at a distance D. I hope the concept is clear now, what I meant when I said measured perpendicular to the mirror. Okay, so this is the knowledge that you need to have. Now let's move a little bit more deeper into the concept. Suppose this is the mirror. Okay, this is the back side of the mirror and an object is kept here. My question is, will image be formed? Will there any image that will be formed if this is the situation? And if you say no, then you're absolutely wrong, because yes, there will be image formed. Now, how to understand this? We know that image is formed perpendicular to the mirror, but there is no mirror perpendicular to this body. Okay, so we will imagine that there is a mirror perpendicular to the body. Okay, we'll imagine. So if it is at a distance D from the mirror, then an image will be formed at a distance D at the back side of the mirror. Now let's rub this thing off. Now, why we are seeing this image? See, who says that rays only come in this direction? There are many rays coming from this object, isn't it? So maybe these many rays are not reflecting, but the above rays like this one, this one, this one, these are reflecting. So these rays are responsible for creating the image on the other side of the mirror. So let me explain by the ray diagram. Suppose we need two rays. So suppose this is the first ray and this is the second ray. We know the image will be formed at the back side of the mirror, and the back side of the mirror, we know the images that are formed are virtual, that is it appears to meet, that is the rays appears to meet. So let us backtrace that thing and see. So the rays are appearing to meet, because after reflection this ray will go like this and this ray will go like this. Okay, isn't it? These rays, if you pull back, then it will appear to meet somewhere, and at that point we will get the image. Okay, so if somebody keeps their eye here, then they will obviously see the image. I hope this is clear. So we can see that the image is formed perpendicular to the mirror. This is the concept that I actually want to instill inside you. Okay, so I hope this is clear, that measured perpendicular, this part measured perpendicular to the mirror, very important, because object distance is equal to image distance. That's everybody know that. I hope this much is clear. This is all about point object when placed in front of the mirror, plane mirror. Now let's move on with our next concept. Now let's move on to our next concept, that is the image formed by an extended object. It's not a point object but an extended object. So it's simple. Look at the diagram. This is the mirror, back side of the mirror. So the object is now extended, it's not point. So it has A on this side and B on this other side. So we know that if it is at a distance D, then this will also be at a distance D. If this is at distance, suppose this is also D, then B will also be at a distance D. So the image formed will be in this fashion. Okay, this is known as erect image, erect, okay, as well as virtual, and at the same distance from the mirror. Okay, now let me explain it in another way. Take another example. Suppose this is our object, like this extended object. So this is A and this is B. This is at a distance small a, this is at a distance small b. Then the object will be formed like this at a distance small a and at a distance small b. So this will be A dash and this will be B dash. Simple as that. This is how the image will be formed in case of extended object. It's similar to point object only. Okay, here the number of points are actually greater than 1. I hope the concept of extended object is clear. Now let's move on to our next concept. Now this concept deals with lateral inversion. We know that the image formed by a plane mirror is always laterally inverted, as we've discussed earlier. Now let's do a problem based on that, and it's a very common question which is very frequently asked in examination. So suppose if this is the clock, this is the object clock, okay, and this is 12 and this is 10. So actually this is 10 o'clock, and if this is the mirror's backside, then what will be the clock's timing on the image side? Simple, we know that this will be 12 and this will be 2. Okay, so this is 10 o'clock this side, here it is 2 o'clock image side. I hope this much is clear, but they will never ask question like this. They will give you a complicated one. Okay, so how to solve in those cases? So the technique is very easy and simple. The first technique is subtract the object value from 12. Okay, this is actually the hour clock, this is minute, and this is second. Okay, now this is 10 o'clock, isn't it? Subtract 10 from 12, like 12 minus 10, you will get 2, isn't it? And you got the answer. Simple as that. Just subtract the object value from 12. But sometimes things becomes much more difficult if the values are complex. Okay, so let's try with some complex value. But if the value is complex, okay, let me take a complex value like 9 hours and 35 minutes and suppose 23 seconds. Okay, then what will be the timing on the image side? You need to find out that. In this case, in order to get it very simply, what you need to do is you need to then subtract this value from 11, 59, 60. What I did, I converted this 12 o'clock into this. This is same as 12 o'clock only. See, 11 hours, 59 minutes and 60 seconds. 60 seconds means 1 minute. So 1 minute, if I transfer this 1 minute here, it will be 60 minutes. And that 60 minutes, if I transfer here, then it will be 12 hours. Okay, because 60 minutes is addition of 1 hour. So I wrote this 12 hour in this fashion. You need to remember this, because if the question is complex number, then you can solve it using this technique. Just subtract from 11, 59, 60 and you'll get the answer. I'll show you how. Therefore, this is the object side. So the result that we'll get on the image side will be 11.59, 60. You need to subtract 9, 35, 23 and we'll get the result directly. This will be 7, 3, 4, 2 and this will be 2. So this will be your answer. Simple as that. I hope the concept of lateral inversion problem that is related to clock is easy now. If the value is simple like 2 o'clock, 3 o'clock, 5 o'clock, 6, 7, 8, use this. If minutes and seconds are involved, then use this. Okay, and you'll easily get the answer. I hope the concept regarding clock problem is now clear. Now let's move on to our next concept. Okay, now this is an important concept. The question is minimum height of mirror for full reflection of body. Okay, the question says that minimum length of mirror that should be there so that the boy can see his full image on the mirror. So let's draw. Okay, before drawing, let's give you the answer. Because in NEET we know that most of the questions are such that it can be solved within 1 minute. So it's better if you just remember the end result of this formula, okay, or the end result of this concept. So let's write down the answer first. So the minimum length of the mirror should be equal to h by 2, where h is actually the height of the person standing in front of the mirror. So let's derive this. Okay, I can leave it here, but for students that wants to know, I will give away the derivation. Okay, so let's see the derivation, how it is happening. So suppose this is the mirror, okay, and a person, this is the back side of the mirror, and this is the person standing at a distance d from the mirror. So the image will also be formed at a distance d from the mirror. Simple as that. If this is the head and this is the foot, then this will be the image of the head and this will be the image of the foot. If this is the eye, okay, E-Y-E, then this will be the image of the eye, E dash. Now in order to get the full image, rays should come from head and it should enter our eyes. Okay, rays should come from foot and should enter our eyes. So let's draw it. So actually what's happening is, let me take a shape. From eyes, a ray should come from the head. Okay, another ray should come from the foot and enter our eyes. Then only we can get the full image of the body. Okay, now let's understand from where is this actually rays are coming and entering our eyes. It is actually coming from the head and it's incident on the mirror and then it is entering our eyes. For the case of foot, what's happening is rays are coming from the foot and incident on the mirror. Okay, the drawing is not good, but I think the concept is being cleared. Okay, so it's coming from the foot and then entering our eyes. Then what are these? These are actually dotted lines because these are actually virtual lines. Okay, your eye will think that the rays are coming from there, from the back of the mirror, but it is just the perception that our eye is having. Okay, and it's false. Nothing is coming from back of the mirror. That's why these images are virtual image. Now the question is, if we rub off this part of the mirror, will it affect the image? Absolutely no, because the only height that is responsible for the image is this much, isn't it? So even if we rub off the above and lower part of the mirror, we'll still get the full image of the person standing in front of the mirror. So let's find out that. So we need to find out this height. Okay, that is the required height of the mirror. So what we will do is we will see and we'll take another ray, and after reflection it will retrace back and it will go there. It will seem that it is coming from that part of the image. Okay, once this is clear, now let's name these points. Okay, now what we will do is we'll take this triangle. Okay, I hope this is clear. We'll take this triangle and we will examine it. Okay, so if we take the triangle, we will see that in that big triangle there are two triangles, like E in triangle EOM and triangle E dash H dash is similar triangle. Okay, now when a triangle similar, two triangles are similar if all the angles are same. Okay, so let's see. So this is the common angle, angle E, for both the triangle, and for the smaller triangle this is 90 degree, for the bigger triangle this is 90 degree. Since two of the angles are equal, the third angle, this one, angle O, is equal to angle H. This has to have. Okay, I hope this is clear. If this is clear, then the rest of the thing is just simple mathematics. We can say from the properties of similar triangle that OM divided by H dash E dash is equal to EM divided by E dash, isn't it? From the properties of similar triangle. Now let's say that OM is X dash. Okay, and H dash E dash is suppose X. Okay, this one. EM, so EM from the figure we can see that it is D, because we have already measured that below, D, and E dash is twice of D. So you can find out that X dash is actually X by 2, isn't it? This is very important. Now similarly we can say that Similarly, if you look into the lower triangle, this one, this triangle, okay, and we'll use the properties of similar triangle. For triangle, I'll write out the triangle E, M, N, and triangle E, F dash, E dash. These two triangles are similar. So if we solve that, and what we will do is we'll say that this is Y dash and this is Y. If we solve this, we will get similarly Y dash will be equal to Y by 2. Now, what we are looking for is the height of the mirror. Now, let's see, height of the mirror, or we can say that is the required height, okay, is here X dash plus Y dash, okay. So X dash plus Y dash. Now we have found out the value of X dash and Y dash. Now X dash is X by 2, Y dash is Y by 2. So we can say that this is X plus Y by 2. Now what is X plus Y? X plus Y, we can say that this is X plus Y, that is the height of the object, isn't it? So you can directly say that it is H by 2, where H is the height of the person. Simple. I hope now the concept is clear. I have given this proof just to make things more clear so that you have a good idea of ray diagram. Okay, I hope the concept is clear. Now let's move on to our next concept. Okay, now let's look into this concept. The question says the minimum height of mirror in order to see the full wall behind the boy. Okay, so it's a bit different from the earlier case. It will be easy once I draw the diagram. So the question says that this is the mirror, okay, and a boy is standing here at certain distance, suppose B, okay, and a wall is behind the boy at a distance, suppose A. This is the wall, and the boy wants to see the image, the total image of the wall in the mirror. So what should be the height of the mirror? This is the question. This is the back side of the mirror. Now this is the top portion of the wall, and this is the bottom B of the wall, and this is the eye of the boy. Now let's see, once it's done, we know if the wall is at a distance A plus B from the mirror, then the image formed behind the mirror will be at a distance of A plus B. Simple as that. This is the top image, this is the bottom image, B dash, and this will be the position of E dash. Okay, now in order to see the full height of the wall, the ray should come from the top as well as the bottom. So let's see, suppose a ray is coming from the top of the wall and it's entering the eyes of the boy. Okay, I have drawn this line dotted because this is virtual line. Okay, it's not actual line, but it seems to come from that position. For this one, a ray should come from the bottom in order to see the full image. Okay, so this is in this direction, this is in this direction, but actually from where is these rays actually coming? The rays are actually coming from this top of the wall, and this is coming from the bottom of the wall. It's reflecting according to the law of reflection and entering our eyes. Okay, so this is the diagram, simple as that. And this position, that is E, let's take another line. Okay, now our diagram is complete. It is similar to our previous diagram. I hope it's clear. Okay, now let's give some name to certain points. This is suppose M, this point is N, this is P, and suppose this is Q. In a similar fashion, we will take the top triangle as we did earlier. So this is the triangle we will be considering, and then we will examine this triangle. Okay, so let me write down and it will be clear. So we can say that in triangle E dash, T dash, and triangle M, N, and E, M, N, E, the smaller triangle, we can say that these triangles are similar. And I have again explained earlier that when our triangles are similar when all the angles of both the triangle are same. Okay, so these two triangles are similar. So we can say that from the properties of similar triangle that MN divided by T dash E dash should be equal to NE divided by E dash. Okay, now MN, let this be X dash. So we can say this as X dash and this as X. Then we can write here X. NE is B. You can see in the diagram at the bottom we have marked it that the distance is B, and E dash is B plus A plus B, isn't it? Simple as that. Now if you solve this for X dash, then it will be X multiplied by B divided by A plus 2B. Okay, similarly we can say it's very easy. If we consider the lower triangle like this triangle, this one, I hope it is clear, this triangle, then we will see that, let me write down the triangle's name, that is in triangle EPN and triangle E dash B dash. If you look at this triangle and we will solve using the properties of similar triangle, then we will get that Y dash, if you take this height as Y dash and this height as Y, then we will get Y dash is equal to Y B divided by A plus 2B. Similar. It's very easy. Now we need the height of the mirror. So height of the mirror, let me write it down, height of the mirror, or we can say the required height or the minimum required height. Okay, this is nothing but X dash plus Y dash. Simple. Now just put the value of X dash plus Y dash in that equation. We will get that it is, we can take B by A plus 2B as common and we can write X plus Y if you just put the value. Okay, now what is X plus Y? X plus Y is actually this height, that, let me take another color, this total height, and that is nothing but the height of the wall, that is X plus Y, isn't it? So we can directly write that this is nothing but B by A plus 2B into height of the wall, the actual height of the wall. Simple. And you just need to remember this formula. This is very important. Okay, so this is the minimum height of the mirror that is required in order to see the full image of the wall. Okay, where H is the height of the wall. Okay, now the question is, if the boy is standing midway between the wall and the mirror, then what will happen? Then what will be the minimum height of the mirror so that we can see the full image of the wall? It will be, that means in this case what is happening, A is equal to B midway. So just put the value of A is equal to B and you will get it. Like if we put it in the equation, we will get H by 3. Okay, so very important. When the boy is standing midway between the wall and the mirror, then the height of the minimum height of the mirror that is required in order to get the full image of the wall is H by 3, where this H is equal to height of the wall. I hope the concept is clear. Okay, if it is clear, then let's move forward, and if it's not clear, then just pause the video, go back and rewatch the video. Okay, I hope the concept is clear. Okay, this is all for this video. It's already 40 minutes and I know it's difficult to concentrate over a very long period of time. 40 minutes is the sweet spot, and don't worry, the rest of the concept I will discuss in my next video. It will be again a 40-minute session, so don't worry, just go through the concept that I have taught, and till next time, enjoy your studies and build your concept, and I will catch you all in my next video. Okay, if you enjoyed this video, then please give it a thumbs up, and if you haven't subscribed to this channel, then please consider doing so. Till next time, bye bye.